Okay, so to ease our way into limiting reactant problems, we're going to look at identifying the limiting reactant in a drawing of a mixture. So the first thing you need to do is actually look at your balanced chemical equation and write your mole ratios between each reactant and just one of the products. So in this case, we're not asked about either of the products in particular. If you're asked for a theoretical yield, then you'll use whatever product you're asked about, okay? For this one, I'm just going to pick the carbon dioxide because it comes first, okay? So you can write a mole ratio between the C2H2 and the carbon dioxide. From the balanced chemical equation, we'll write an equivalency. So every 2 moles of C2H2 that react, we can form 4 moles of carbon dioxide. And we'll do the same for the other reactant, the oxygen. For every 5 moles of O2, we can form 4 moles of carbon dioxide. So then what we're going to do is we're going to convert the actual number of moles of each of these reactants, the C2H2 and the O2, and find out how much carbon dioxide we can actually make. First of all, if we use up all of the C2H2, and second of all, if we use up all of the oxygen. Now, we might get different amounts that can be formed because we don't necessarily have stoichiometric or exact reacting quantities in our mixture, right? You could have anything. You could have 1 mole of one thing and 26 million moles of the other, right? Real life can be like that, okay? So first of all, of which reactant are there the most initial moles? Well, we should just count them all up, right? So this must be the C2H2. Carbon is black, hydrogen is white. That's the general scheme of things. So we've got 1, 2, 3, 4, 5 moles of C2H2 is what we've actually got. I guess I can just write that in there, couldn't I? And then of which reactant are there the least initial moles? Hang on, I didn't even read that correctly at all. I was just like reading how many of each one we got. We've got 5 moles of C2H2, and we've got how many moles? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 moles of oxygen. Okay, so that is our starting quantity. So obviously, in terms of just plain old moles, we've got more moles of O2 than we have of the C2H2. So I'm just going to be sort of pretty sneaky and just do this. Right, so we've got more moles of the O2. Get in there. And then we've got, box please, less moles of the C2H2, but it really depends on what the reaction ratios are as to which one's the limiting reactant. Okay, so we're going to have to like work it out, right? So it depends on the formula, it depends on how much you start with. Okay, which reactant is the limiting reactant? So we're going to start off with that 10 moles of O2 and convert it to the number of moles of CO2 you could possibly make. Okay, so moles of O2 are going to go on the bottom, just like when we're converting moles of one thing to moles of another thing. It's a mole ratio to moles of CO2. So we know from that ratio, from the balanced chemical equation, 5 moles of O2 will yield 4 moles of CO2. Okay, so that's how you make sure you get them the right way round. Okay, so what we're going to compute is 10 times 4 divided over 5, 4 divided over 5. And that is going to give me 8 moles of CO2 that we can possibly make. But just because you got an answer doesn't mean you're at the end, okay? Because then we need to rinse and repeat that for our other reactant, which was our C2H2, okay? And whichever number of moles is the least amount is going to be our limiting reactant, okay? So we start with 5 moles of C2H2. Okay, give me a minute, buddy. So our balanced mole ratio C2H2, 2 moles of C2H2 make 4 moles of CO2. Okay, so that is going to give us overall 5 times 4 over 2, which is 2, right? 4 divided by 2. So that should be 10 moles of CO2. So this is the important take-home message, okay? You can't make 10 moles of carbon dioxide from this particular reaction mixture. Why? Because you've only got 10 moles of oxygen. When you've used up all those moles of oxygen, you've made 8 moles of carbon dioxide. And then what you have left over is a few more moles of the C2H2 that is in excess, okay? So in terms of our theoretical yield in terms of moles. This would be our theoretical yield, and it means the oxygen is the limiting reactant. It limits how much product you can make. Once you've used up all of the limiting reactant, you've got extra left over of the other reactant, and that is what we call in excess. You've got more of it than you need. So you can never make that 10 moles of carbon dioxide because you've run out of oxygen. So the limiting reactant is the O2. Okay, so let's do one more, okay? We got a reaction between a gas and a solid. That's fun. Okay, so let's write our mole ratios. Okay, so for every 2 moles of carbon, you can make 2 moles of carbon monoxide. For every 1 mole of oxygen, you can make 2 moles of carbon monoxide. Okay, darling. Okay, so then we got to look about how many moles we actually have. Okay, so 1, 2, 3, 4 moles of oxygen is what we actually have in our mixture. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 moles of carbon is what we have there. Okay, so we're going to have to convert that to how many moles of carbon monoxide we can actually make using the mole ratio. So for every 1 mole of oxygen, we can make 2 moles of carbon monoxide. Okay, 4 times 2 is going to be 8 moles of carbon monoxide, but we don't know if we can make it that because we've got to look at the moles of carbon. Okay, so remember, for any limiting reactant problem, you have to look at each reactant you have. You might have 2, you might have 4, might have 3, I don't know, right? You have to do this for each reactant to see which produces the least amount of moles of product, and that is going to be your theoretical yield, and that reactant would have been your limiting reactant. Okay, so 2 moles of carbon monoxide is formed from 2 moles of carbon. 2 over 2 is 1. So that tells me I could form a maximum of 10 moles of carbon monoxide, which can't happen because I've run out of oxygen. If you can hear a distressing noise, that is my cats trying to eat the blinds. Okay, so which reactant is there the most initial moles? Well, we had the most initial moles of carbon. So you've got 10 moles of carbon. Of which is there the least initial moles? Cats, no. None. The least initial moles we have is of the O2. Which one's the limiting reactant? It's going to be, in this case, the oxygen. Okay. Get out of here. All right, then. No, stop it.